All right. So give me a second to share my screen. What we're going to do is go over each of the problems from that 7.2 pre-notes check. All right. So you had two questions here. The first one said convert 125 so it has a base of 5 raised to an exponent. All right. What was the answer for the first one? 5 to the third power. Good. So 125 we can rewrite as 5 to the third power. These are the same thing, essentially, right? And a lot of people, as I was going through and checking each of your answers there, did really well with the first one. So dealing with some whole numbers. Gets a little bit trickier when we deal with fractions. What was the answer to number 2? So you have 1 over 16. That's the same thing as 4 to what power? The negative second power. So some of us just put positive 2. So we recognized 4 squared gave us 16. But anytime that we see that fraction, right, a light bulb should go off in our head immediately that it's a negative power for our integer. Some people lost time. I understand. No worries there. Like I said, this doesn't count for any points, for or against you. So don't worry about that. But we need to make sure that we understand some of our integer properties here, right? How can I write something so it is a base raised to an exponent? And the reason that we need to know that and kind of understand that idea is because it's going to apply to help us solve exponential equations. All right. So that's what our objective is today. We're going to go through and solve some of these different types of problems. First thing we need to kind of look at is what exactly an exponential equation is. All right. It's going to sound pretty straightforward. It's an equation. So this first line here, an equation with the variable in the exponent, right? Seems pretty obvious that that should be the case since it is an exponential equation. And underneath of that, we're going to put a couple examples. So we're not going to solve these, but just to kind of give you a heads up as to what to expect when you see an exponential equation. It could be an exponential function like 2 to the x set equal to just a constant. All right. So that's an example of one exponential equation. Instead of just a number raised to x, maybe it's a number raised to 2x. Right? Or some expression, maybe it's 2x plus 10. And that's also going to be set equal to a constant. So again, we're not solving these are just examples. It could be maybe an exponential function set equal to another exponential function. So it could be maybe 5 to the 2x minus 1 equals 125 to 3x. These are all different cases of exponential equations that we might see and eventually be able to solve. Okay. Everybody good so far? So let me ask you a question. What's a really easy equation to solve? Like if you were just to make up a math equation. All right, so 2 plus 2, you're just adding constants, but I mean an equation itself. So setting something equal to, like a linear equation. 2 plus x equals 6, right? What would you do on both sides to solve? Subtract 2, right? So these easy 1 and 2 step equations, like 2x equals 4, right? What would you do on both sides? Yeah. Divide by 2. Anything where I can just either add or subtract, multiply or divide to the opposite side, I get my variable by itself. Those are our easy equations, right? Those are equations that we're the most familiar with since it's probably the first equation we learned how to solve. So we're comfortable with it. What we're going to do is try and rewrite some of these exponential equations, right? Because these look like a mess right now. But there's a way for us to maybe rewrite it so I can create a linear equation, and then I know how to just move some things over and solve automatically, right? Getting it to a point that we're the most comfortable with. And that's what we're going to do. And what we're going to do to get to that point is relate what we did in this check. So rewriting an equation so we have the same base on either side is actually going to help us to get a linear equation to solve. All right. So our first step, and actually the only new thing that we are going to encounter today, the most important is to rewrite each side of our equation whenever we're given this exponential equation with a common base. All right. So rewriting each side so I have the same base on both sides of my equation. All right. And that seems kind of wordy. So let's see what that looks like in an example. So we're going to do what we usually do, use example 1 to kind of help us form some steps. On the left-hand side of example 1, I have 3 to the 2x power. All right. I'm going to keep that as is. And I'm going to ask myself, well, in order to get common bases, right, because I want the same base on either side, how might I be able to rewrite 27 so it has a base of 3 as well? 3 to what power gives me 27? I do. Yes, somewhere over here. So 3 raised to what power gives me 27? The third power. Good. And that's how we can connect what we did in the little warm up there to what we're going to be able to use today to help us solve. All right. So my first step is to rewrite so I have a common base. My second step is to then use some of my exponent rules to simplify my exponents. Well, right now, my exponents are as simplified as they can be, right? I have the 2x and the 3. I can't break those down any further. I can't combine anything. So although step 2 doesn't apply in this example, we will see it apply later on, right? Everybody with me so far? So rewrite the bases, use exponent rules to simplify. From here, what we can do if we have the same base on either side, all right? An algebra step that we can take is to then set the exponents equal to each other. So if I have 3 to the 2x and 3 to the third power, I notice I have the same base. What I can do with those exponents is set them both equal and create a new equation, which is 2x is equal to 3. And what would I do to solve for x from here? Divide by 2. Nick, is that what you're going to say? Divide by 2, so I get x is equal to 3 halves, or if you're a decimal person, 1.5. And that would be my final answer. So you see that we took something from an exponential equation, changed the basis to help us get it into a linear equation, which then helped us solve, since that's something that we're used to solving, right? It's easier 1-step, 2-step equation. What was my last step? What was this last piece here? What did I do? From this step to get my final answer. Okay, or just solve for x, right? Don't overthink it. Just solve for x. Okay, so that's, nah, it's all right. So just really easy solving for x. Any questions about that first example? Okay. Let's take a look at the next one. A little bit of a typo here. So it should say 2 to the 5x minus 1 all in that exponent is equal to 32. So just change what the left-hand side says, because the minus 1's technically down below there, but it should be in the exponent. We're going to do the same thing that we did in the last example. So my first step is to rewrite to have a common base. So on the left-hand side, I have 2 to the 5x minus 1. I have to change that constant term so it also has a base of 2. Well, 2 to what power gives me 32? 5. Good. What do I do from here? What should my next line be? Nick? Set the exponents equal to each other. So what does that look like in the next step? 5x minus 1 equals 5, right? You just drop those bases. Like an EDM DJ. And now what do I do? How would I finalize this problem? Add 1 to both sides, right? This is just a 2-step linear equation. So I have 5x equals a 6. How do I get x entirely by itself? Divide by 5. Good. So you have x is equal to 6 over 5, or 1.167 if you're a decimal person. Deal with like averages and stuff all the time. Well, it's 5 goes into 6 one time, and then you have 1 divided by 6. So if you're 1 for 6, and baseball helps, to be honest with you. Sean, I'm sure you could attest to that. Like, you had 1 for 6 on a weekend, you're hitting 167. It's just terrible. Right? Any questions about example 2? Okay. What do we notice about example 3 that's a little bit different than what we've seen so far? Right. Both sides are exponential functions. So what I would suggest doing, so we don't confuse ourselves too much, change just one of the sides, right? So start with probably the simplified base that you have. So 2 to the 3x, that's about as simple as I can get, right? Number 2. Some of those prime numbers like 3 raised to a power, 5 raised to a power. So we'll keep the left-hand side the same. On the right-hand side, I'm going to change 4. So it has a base of 2. Well, 2 raised to what power gives me 4? 2. However, I still have that exponent there. What's the extra exponent that I still have on that side? X plus 1, right? That whole expression, x plus 1. So you're raising 2 squared to the power x plus 1. So that's why I included my parentheses. When you're changing the base, sometimes it's helpful to organize your work in a way that you just change the base, keep that in parentheses, and if there's still an exponent, write that on the outside as well. You're still raising it to the x plus 1 power. Okay? Is everybody with me so far? Because this example is a little bit different than what we've seen before. So the left-hand side is going to stay the same. The right-hand side, if I raise a power to a power, what operation's taking place between those two terms? You're multiplying. That's one of our exponent rules. So anytime I have a power raised to a power, I multiply those numbers together. Okay? So essentially, this is really 2 as my base still. And I'm multiplying 2 times x plus 1. So what I'm going to do is just rewrite that in this form. As we progress through our examples, you'll start to realize that you can just multiply them together. You can skip this step here. But I'm just doing that so we all are aware of the fact that if anytime I have a power raised to a power, I'm multiplying them together. All right. And that's going to come up the most often. That's that second step, which is to use exponent rules to simplify. Okay. Are there any questions about that idea? Because that's something that we really need to make sure that we harp on and pay attention to. Okay. Notice that I have the same bases on each side, right? So what can I do with my exponents now that I have the same base? Set them equal to each other and solve for x. So how would I solve this equation? What do I have to do on the right-hand side? What's that process called? Distribute, right? And when I distribute, I'm multiplying those two terms together. So I have 3x is equal to, what happens when I distribute? I get 2x plus 2. Give everybody a chance to copy that down and get caught up. And again, our main objective, our goal was to make sure that I have that easy linear equation, that 1 or 2 step equation to solve. So what should I do now in order to get x by itself? Subtract 2x on both sides, right? So I get x is equal to 2. Good. Any questions about that example? Because that's the first time that we're seeing that exponent rule come into play now in that example. Everybody good with that? What can I do to check my answer? So say I get down to x equals some number. What can I do with that number to make sure I have the right answer? Plug it back into the original equation. So let's just do that for number 3. If I plug in 2 in for x, I have to do it on both sides, right? So what's 3 times 2? 6. What's 2 to the 6th power? 64. All right, so I have 64 over here. What should happen on the other side? What number should I get? 64. Well, what's 2 plus 1? What's 4 to the 3rd power? 64, so I know that I have the right answer, all right? So anytime that you get a value, you can plug that back in for x to make sure that you have the correct answer, all right? And you should get the same thing on either side of your equation. Everybody clear with that idea so far? Everybody good? Okay. We're just going to take care of these 3 problems at the top of the page. See how much time we got here. 15 minutes or so. All right, cool. And then I'll explain what the homework assignment is, and then we'll be good for today. All right, sound good? So in number 4, problem's a little bit different. The reason for that is because I have to do something on both sides now. I have to change my basis. Instead of the examples that we've seen before, where I keep one side the same, I've just changed the right-hand side. Just change this, just change the right. Here I have to change both, all right? And there is a fair amount of, maybe a little bit of guess and check involved in this process. For example, off the top of our heads, we might think, well, 16, that's 4 squared, right? If I'm changing my base. But there's not a base of 4 that I can change to get 8, right? It's gonna be a fraction, not a whole number, something that I'm not really used to. So we need to start thinking about some numbers, and I would say to start small with this, where you can have the same base on both sides. Anybody have any ideas for number 4, what I could make my base? 2, right? If I make 2 my base on both sides, what do I have to raise 2 to? What's the power that I have to raise it to get 16? So 2 to what power gives me 16? 4. But what else is on that side as an exponent? 3x, good. So I'm just rewriting the bases. What about on the right-hand side of that equation? 2 to what power is going to give me 8? 3. So like I said, this question is a little bit different because I'm changing both sides. Everybody follow along with that? What operation do I have to do when I raise a power to a power? Well, not distribute. right, multiply, right? It's not always going to be distributed, but you're right. You're multiplying. So when I multiply these two things together, I get what? 12x. On the right-hand side, because I have the same base, what can I bring down? So if I'm dropping these bases here, 12x is equal to 3. Good. If I have the same base, I just set the exponents equal to each other. And then what do I do from here to solve for x? Just divide by 12 on both sides. Good. And I get x is equal to what? How does that simplify? 1/4. Or if you're a decimal person, 0.25. All right. Any questions about that example? Okay. Let's do the next one. Let's hear from somebody different. I want somebody to tell me what they think that base should be for number 5. What should I change 27 and 81 to? What's a common factor that they might have? What should my base be? And if you need to use a calculator, it's totally fine. So I'm fine with whatever you need to do. So if I had 9, all right, I know that 9 squared gives me 81, but what's 9 to what power gives me 27? Right, I know 9 times 3 gives me 27, so think a little bit smaller. What's another factor of now 9, 27, and 81? Just think real small. What's the square root of 9? 3, right? So if I make the power 3 on both sides, nice job, Brian. Or if I make the base, 3 on both sides, 3 to what power? So let's continue to work with this. 3 to what power gives me 27? 3 to the 3rd power. And what else is left over there on my left-hand side? 3x. On the right-hand side, 3 to what power gives me 81? 4th power. We need to make sure that we are studying and really understanding of our, exponents here. All right. You have to use any resource you can to get that. That's fine. Everybody with me so far? So what should my next line be? Let's hear from somebody new. What should my next line be? Well, so okay, so what do I have to do with the exponents? Right, I'm multiplying 3 by 3x. So I get 9x is equal to what? 4, right? If I'm setting those exponents equal to each other, I'm going to simplify using my exponent rules, set it equal to 4. And then I divide by 9 on both sides to simplify, right? So I get 4/9, which is also just 0.44. All right. Any questions about that example? All right. Last one. I have 5 to the 3x is equal to 1 over 125. Whenever we see a fraction, all right? Because my left side is going to stay the same. So I have 5 to the 3x, right? Which means what should be my base on the other side? Should also be what? 5. Well, when we see a fraction, that automatically should trigger that we have what kind of number as an exponent, positive or negative? Negative. Nice job. So it's going to be 5 to a negative power. And what is that number? -3, right? 5 times 5 gives me 25, times an additional 5 gives me 125. So 5 to the -3rd power. Remember, whenever we see that negative, it flips to a fraction. So it's really 1 over 5 cubed, which is 1 over 125. What do I do from this point? So now that I have the same bases, set the exponents equal. So I have 3x is equal to -3. How do I solve for x? Divide by 3, and what's my final answer? X equals -1. Notice that if you plug -1 back in, you have 5 to the -3rd power, which is equal to 1 over 125, right? So exactly what we kind of just walked through in that process when we changed it to the same base is how we actually can check our answer, all right? Any questions about that example or anything that we've done today in class? Okay. So then your assignment for tonight, I changed it a little bit if you already looked in today's folder earlier for whatever reason. It's on page 464. You're just doing 9 through 13 odds, which is 3 questions. Okay. This is a really easy assignment for you to complete. It's got a mix of some problems that we saw today. So you see an exponential set equal to a constant, exponential set equal to an exponential, where you don't have to change both sides, and then one where you do have to change both sides. All right. So make sure that you get those 3 problems done. When you come into class tomorrow, we will go over it and then just do a quick little 3-question practice with this. Should be a relatively short day since we have the shortened Wednesday. And then Thursday, we're going to pick up with the bottom of this note sheet. So make sure that you hold on to this. Okay. So we're going to be talking about the same process, but then with inequalities. All right. If there are no questions for me, those of you that are at home, go ahead and sign off. Enjoy the rest of your day, and I will see you all tomorrow. Those of you that are here, just wait for the bell to ring. All right.